So we're going to go through coordinate geometry and how we apply it in differentiation. Now, one of the first things we look at is finding tangents of curves. Now, it's nothing that we haven't done before, but this time around we're doing it where there's no instructions as to how to break down the steps. So obviously I write down a set of steps. So number one, find the x and y coordinates. And then number two, find the derivative. Then substitute the x value into the derivative, and then we sub x and y with the gradient into our normal linear equation to solve it. Now make sure you do it in this particular order, because quite often people forget what values they need to look for. So by doing it in this order, you shouldn't forget. Let's try it out and see what happens. Okay, so this is an example of trying to find the equation of a tangent. So let's just go through the steps and try and do it. So number one, we want to try and find the x and y coordinates. Now we know x is equal to -2. So let's sub that in. Y equals to 2, we'll sub in -2 for the x, like so. Then we can expand it. -2 cubed is -8 times the 2, plus 2 squared, which is a 4. And because it's negative, we square it, we get a positive. So we have -16 plus 4 giving us -12. So then our coordinate is -2, -12. Then, part 2 is we differentiate this first. So dy dx gives us 6x squared plus 2x. If you don't remember, you take the power down and you multiply it. Then you subtract the power by 1. So part 3, we sub in our x value, which is -2. So dy dx is 6 times -2 squared plus 2 times -2, giving us, whoa, I don't know what happened there, giving us a 24 minus 4, which is equal to 20. In part 4, we sub it all into our equation, y minus y1, which is here, equals to m, which is there, x minus x1. So then y plus 12 equals to 20x, I'm just going to expand it, plus 40. So then y is 20x plus 28. Alright, so just a reminder for all the general coordinate geometries. So parallel lines, remember the gradients are going to be equal. So the parallel line is going to be equal to the original. For perpendicular lines, we have -1 over the original. For angles of tangents, we have the gradient equals to tan theta. Then we use the calculator to solve it if we need it. And then finding points of intersections, we would use simultaneous equations to solve for it. So, at the point 2, 1 on the curve y equals to 1/4 x squared, a line is drawn perpendicular to the tangent at that point. So, let's just go through the questions. A. Calculate the coordinates of the point Q. Now, we firstly need to know, if you go through this, let's have a look. We have a line drawn perpendicular to the tangent, and then it meets at the curve at point Q. So, if you have a look here, there's a tangent on this particular line. And with the tangent, you then need to find the perpendicular line. So what that means is we need to do this in order. 1, find the tangent. Now this time around, the points given to you, I should probably put an arrow on. Because the points given to you, we don't need to find the x and y coordinate now. We just simply need to find the gradient, then we essentially have a tangent. But if you think about the slide before, the perpendicular gradient is the same as 1 over m, and we don't need to know the full tangent to find the gradient of, to find the line of the perpendicular line. So this shouldn't really say find the tangent, it should really say find gradient of tangent. So let's find the gradient of a tangent. How do we do that? Well, always take the derivative, because the derivative gives us the gradient at any tangent. So if you take the derivative, we have a half x, then sub it in the point where x is equal to 2, then dy dx is a half times 2, which is a 1. Should probably put all the steps in. Then 2, we find the perpendicular line. Now we need to actually find the full line to find the point. If we only find the gradient, that doesn't help us. It should be clear as to why once I start doing it. So the perpendicular line is, oops, I did a typo, I'll re-record that in a second. So we want -1 over 1, which gives us -1. And once we have the gradient, we still need to know how far it's shifted, which is why we need to find the line. So once we've done that, let's find the actual line where we have y minus, we're going to substitute the point in which we have listed as an arrow there, which is 2, 1. We're going to use that to find our perpendicular line. We substitute all that in, we solve for it. So then we have y equals to -x plus 3. Then once we have that, we want it to intersect. So then step 3, we have our simultaneous equations. So we make the two y coordinates equal. So then we have -x plus 3 equals to quarter x squared. If you're not entirely sure on what I did, I just make the two equations equal like that. Then we don't like numbers in front of our quadratics, not quadratics, the squared term, so we're just going to multiply each side with a quarter. Oh, sorry, with 4. I'm going to get extra powerful. Then just rearrange it so we have x squared plus 4x minus 12, giving us a 0. So the ones where this will give us a plus 4 in the middle would be if we have a 6 and a 2, and it has to be a difference because there's a negative right there. So that's x plus 6, x minus 2. So then x is either equal to 2 or -6. Now obviously we already have the coordinate where x is equal to 2, so the other one we want is x equals to -6, which is at point Q. So then subbing x equals to -6 into either equation, doesn't matter which one, I would recommend the linear one. So then y equals to -6 plus 3, giving us a 9. So then Q is equal to -6 and 9. Alright, so now we're up to part B, calculating the magnitude of the angle that the line passes through Q and the point 2, 1 makes with the positive direction of the x-axis. Now, if you recall, on the previous part, we have y equals to -x plus 3 for this particular equation. So, because of that, our gradient is equal to -1. So we just make tan theta equals to -1. Now, in order for this to happen, we can have two different things. but when you put it in your calculator, the answer you will get is negative 45 degrees. However, if you have a look, this says makes with the positive x direction. So we want this part. Now, if you have a look, there's our negative 45 degrees. This makes 180 degrees in total, like so. So what that means is we need to do, in order for us to find the angle, we will do 180 degrees minus 45 degrees, giving us 135 degrees. So that will be the angle that it makes.